Hey y'all, this is just going to be a little help for the Pythagorean theorem pile-up that you guys are going to practice today. It is just some good practice on the Pythagorean theorem. If you need to work on something else like yesterday's lesson or something from earlier in the week, you feel free to do that. That's just fine. I apologize for not being there. So, Pythagorean theorem, you guys are familiar. We've got right angle triangle, and it is a squared, b squared, c squared. So when you're looking at this, it will walk you through kind of where to start, and I would suggest that you start down here with this guy. Just as a quick reminder, so 10 centimeters right now is my hypotenuse, so that's going to be my c squared, and 8 is going to be either a or b. S could be either a or b, doesn't really matter. So you'd set this up like this, where c is our 10, and 8 is one of these, and s is one of these. Simplify it for yourself. So 8 squared is 64, 10 squared is 100, so we've got something here, s squared plus 64 equals 100. I would probably go ahead and subtract 64 from both sides, and you will get that s squared is going to be 36, which means that s is going to end up being 6 because the square root of 36 is 6. So s here, I can cross this out and I can write that this is 6 centimeters. Okay. Thing just to be careful there is just like, which one is C? Are you looking for C or are you looking for one of the short legs? Okay, eventually you're going to get to a place where you are dealing with something that looks a little bit different. So if you keep going, for example, with this orange one where you've got one side is 6 and one side is 9, I've done the work for you over here, and there's just a separate little picture. Double check yourself by all means, but you should end up getting that this side right here is about the square root of 45. Y'all know that the square root of 49 is 7, so that means that this one is going to be a little bit less than that, so 6 point something, something, something. But I would rather that you keep it actually as the square root of 45 because that is a much more correct answer, especially because you're going to keep going here. And this is really where I would like to help you today. So if you want, I will wait for just a second. You can pause the video to get any of this stuff down. Okay, hopefully you're able to pause that. But let's talk about this purple triangle right now. In this purple triangle, we've got a hypotenuse that is 12. We've got a missing side that is u, and then we have this side that is the square root of 45. And this is where you just might be a little bit less familiar if you haven't worked with square roots like this. So I'm going to leave my 12 squared where c is. I'm going to let u squared be the second one. And really all I'm going to write here is 45, the square root of 45 squared. I know that you could replace this with 6 point whatever this is equal to using a calculator, but this is actually going to work out way prettier for us, and I want to show you why. So I'm going to move everything over here for a second, and what I've done is I've gotten the actual value. So the square root of 45 is approximately 6.708, and I want to show you how this is going to change if I use that value instead of the square root of 45. So what's going to happen, each of these is going to become 144, and we're going to get the u squared is going to stay the same, the u squared is going to stay the same. So like this part of the equation will not change at all. Over here, the square root of 45 squared, anything squared, just like if we had the square root of 9, you guys know that that's 3, right? And you know that 3 squared is 9. Well, if I took the square root of 9 and I squared it, presumably that will also give me 9 because 3 and the square root of 9 are the same. So this right here is basically 3, just like this is 3. Like those are the same thing. And I've just squared them. And if 3 squared is 9, square root of 9 squared better also be 9. So in this case, square root of 45 is just going to be 45. It's going to work out real slick. The square root of the square, the square of the square root of 45 is 45. But if we have to do, if we have to do this value squared, we end up with a much less nice number to work with. Now, 44.997 is basically 45. I hope that you see that. But because we had to do some rounding here, because we weren't able to use everything, because this is approximately equal to 6.708, there's actually a lot more that goes on here, we end up getting, sorry, I keep accidentally erasing stuff. We end up getting kind of a messier thing. And so Now I'm going to subtract over here. I'm going to have a decimal. It's going to be all gross. Whereas up here, I can just be like, all right, cool. Minus 45, minus 45. U squared is 99, and thus U is going to be the square root of 99. So hopefully this is helpful. If you do end up using decimals, it's not the end of the world. You might get a little alarm from Desmos because I asked it to only give you guys exact answers. So square root of 45 would work, but this 6.708 would probably not give you the little check. But if you want to double check and just use a calculator, that's perfectly fine by me. I'm not super stressed about that. I just kind of wanted you guys to err toward these square roots. So that's the first 3 answers for you. Let me know if I can be helpful. I will see you guys hopefully on Monday. Again, my apologies that I'm gone today.